This presentation is about work on the pelagic ecosystem of Labrador's largest estuary, which is Lake Melville. The length of Lake Melville is 140 kilometers, and it spans an area of more than 3,000 square kilometers. There are 4 coastal communities distributed along the Lake Melville estuary: Sheshe, Northwest River, Happy Valley Goose Bay, Rigolette. And all these communities are part of different land claims, indigenous land claims, covering the Nunavut Community Council land claims, the Innu Nation land claims, and the Nunavut government land claims. The Lake Melville estuary faces double pressure from climate change and from increased anthropogenic activities. Regarding climate change, the region has been facing a increase in temperature anomalies, a positive trend since the late 90s, with higher temperatures across the Labrador coast, including in the Lake Melville area, which results in warmer water temperatures. On top of that, the main tributary of Lake Melville, being the Churchill River, has been harnessed in the 70s to create the Churchill Falls hydroelectric project, and that had as a result that flattened the river discharge curve, the Monte River discharge curve, with a smaller peak during the melting season in the spring and a more uniform distribution of the river discharge. However, there's still a peak in the spring that prevails, which is the yellow line on the graph there. But with the construction and completion of the ongoing Muskrat Falls hydroelectric project further down the Churchill River, there's a risk that this curve is further flattened, which will further change the hydrography of the Lake Melville estuary. To understand how the pelagic ecosystem of the Lake Melville estuary is related to this hydrography, and how it could change with the ongoing changes in the climate and in the related to anthropogenic activities, we mounted the project FishDip, which stands for Dam Impacts on Pelagic Fish Ecology in a Subarctic Estuary, which is funded by MEOPAR. And the main objective is to understand how the operation of the Muskrat Falls Dam will affect fish ecology in Lake Melville estuary, and also to provide baseline information for science-based management of fisheries in Lake Melville, knowing that there's a subsistence and recreational fishery mainly for rainbow smelt, but also for trout and salmon in the lake. So as part of the FishDip project, we conducted first summer surveys between July and August 2018 and 2019, and we during these surveys we covered all the black lines that you see on the map, which is the upper part of Lake Melville, so Goose Bay, the Narrows, and then the upper part of Lake Melville, to really map the distribution of fish and zooplankton using fish finders, fish echo sounders mounted on small research vessels. We also sampled the 10 different stations, and these stations were revisited in the winter at the onset of the cold period, when they will have more release of the dam to produce electricity in the cold period. So we've went back on the lake when it was frozen in winter in February 2019 and 2020 to revisit those 10 stations. And at each of these stations, we were doing hydroacoustics, CTD profiles, plankton nets, and also collected water for eDNA analysis. On top of that, we've deployed a long-term mooring with an array of temperature and salinity sensors at each with a vertical resolution of 5 meters, where the star is on the map to your right, which is just at the mouth of the Churchill River. And that allows us to really see the change in the hydrography throughout the year cycle. We captured 9 fish species in the gill and fish nets that were deployed in August and September. And we also got the signal of 102 fish species with the eDNA of very diverse group of families. The most abundant fish larvae that were collected were rainbow smelt. They were virtually the only species that were captured in terms of ichthyoplankton during our summer surveys. One of the most striking characteristics of the hydrography of Lake Melville is the really strong stratification prevailing throughout the year. As you can see on these graphs, so on the top part you have temperature and the bottom panels are salinity profiles, and then for each of these panels, the left is Goose Bay and the right is Upper Lake Melville, so it goes from west to east. and engraze the bathymetry. But what you can see is you have a really strong stratification prevailing both in summer and in winter for both years that were sampled, 2018 and 2019, with a fresh water layer in the top 10 to 20 meters, and then more saline Atlantic water just below the alloc. And what you can see is that it goes from salinity of 0 to more than 24 within just a few meters. So really steep gradient, really strong stratification. This water stratification drives the vertical distribution of fish in the estuary. What you can see on these panels here on the left are ecograms, 5-minute ecograms with the depth on the y-axis. And the warmer the colors, the denser are the biomass of fish and zooplankton. And really what you can see is that in summer you have an aggregation at the picnoc line, and using nets we confirm that the aggregation was mainly or almost exclusively rainbow smelt larvae. In contrast, during both summer and winter, older adult fish were distributed below the picnoc line. That suggests that the freshwater layer is really a refuge for the rainbow smelt larvae, and we know that rainbow smelt is one of the main forage species within Lake Melville, so a really important species as a prey for seabirds, other species, and also marine mammals. Because of its high abundance and ecological importance, we started looking at rainbow smelt as a sentinel species within Lake Melville estuary. So we started measuring its larval abundance at the different stations in summer. And what we saw is that it was negatively correlated with temperature and positively correlated with salinity. So the warmer the sea surface temperature, the lower abundance of larvae we had, and the more saline the surface water, the more abundance of larvae was there. And we think that this is not necessarily related to a selection of the sites, but rather as a survival of the larvae as they drift to different locations within the lake. So our main conclusions are that there's a diverse estuarine ecosystem within Lake Melville with dozens of different fish species. The warming trend because of climate change could negatively impact forage fish, such as rainbow smelt, but this negative impact could be dampened by the ecological plasticity, knowing that in the Lake Melville area, we are really at the northern range of the distribution of rainbow smelt, and we know that they can survive in warmer temperature further south. So there's still probably some room for warmer temperatures. Our results doesn't suggest any direct impact on larval survival from the change in temperature from the dam, because it is forecasted that the dam will decrease the temperature at the surface in spring and summer. However, by changing the monthly river discharge and stratification, especially in summer and spring, it could negatively impact the larval survival of rainbow smelt, because we know that this freshwater layer is really critical as a refuge for the larval smelt larvae in the region. To finish, I would like to offer special thanks to Doug Blake from Northwest River and also to Adam Templeton for the logical support during fieldwork. I also want to emphasize that this is work from two master students, Tiffany Small and Jordan Sutton. Each of them have a poster during that conference, so I invite them to visit their poster and ask them some questions more specifically about these projects. Thank you.